Welcome everyone to another lesson in remote sensing techniques, and in this lesson we will concentrate on the questions how we can do a supervised classification on Landsat data. So for first time, or maybe for first understanding how this works, we should consider the terms parametric and non-parametric signatures. As you maybe know from our last lesson in unsupervised classification, we can create something like a feature space in erdas Imagine using the image to feature space tool, and doing this for the bands number 4 and bands number 3 gives us a really good possibility to differentiate between water here in the lower left corner and vegetation in the lower right. And just make a new plot of it, so we have 1 pixel with water and 1 pixel with vegetation. And as you can see here, due to some random signal behavior here, we have something like an ellipse here and over here as well, and we can use these ellipses to plot a frequency in the band number 4. And as you can see here, we have nearly normal distribution over here. This is a quite wide normal distribution in the band number 4, and we can describe these probability density functions with some statistics. So we can say, okay, the mean value is over here, mean here, and we have some standard deviation on them as well. But let's have a look on the normal feature space. So the normal feature space looks like this. Just check again with the first slide. And you can also arrange a signature file or a class just by looking on the feature space and masking an area out of it, like this. So this should be one class. And if you're looking on the frequency on the band number 4 maybe, you will see that you have something like a normal distribution in the first part, because you will have a lot of more pixels over here instead of over here, but it doesn't start on the value of 0, and then it is just cut it off because of the rectangle area here, and you will maybe have something like a stable frequency belonging to this box, and then a second cutoff in the end of the box. So you cannot describe it probably using a probability density function, and therefore you are introducing the term non-parametric feature, because it's not behaving something like a its behavior cannot be described with a probability density function. But let's go back again from PowerPoint to this Landsat scene I'm using all the way. So this is Berlin again, and first of all we have to make clear what is the main difference between doing an unsupervised classification and using a supervised approach. For the unsupervised classification, you are just concentrating maybe on the mathematical behavior of the Landsat scene and its reflectances, or maybe its digital numbers in this way. And due to the mathematically or geometrically setup of this reflectance, you will create your classes or also your signatures, and this you are hoping to find your scene represented in this segmentation of the area. The supervised approach is a little bit different. For the supervised approach, you are designing something like an example, and from this example, erdas or the approach tries to find other areas in your Landsat scene that belongs to the spectral setup of this example. So first of all, we have to make clear how to gain these examples for this spectral behavior, and therefore we will create some AOIs, or maybe area, or also known as areas of interest. Therefore we will need the Landsat scene as well, and you can find AOI over here, and there we go with the tools. So you can create a tool using a polygon or a rectangle or circle. I'm normally using polygons because they are easy to create, and you can really, or you can arrange the position of your polygon very easy to your desired area of interest. So first example, and maybe this is the best example you can probably give everyone in every kind of software, is to create a signature file or class just representing water. Therefore, I've created this kind of polygon, and I have to extract the information in the pixels to a signature. And therefore I will open the classifier and signature editor. There we go. And you can create new signatures from AOI. You can see it over here. Create new signatures from AOI using this tool. This will extract all the band information in this area and provide a signature name. You can find the color, which is the mean color of the area of interest, and you can also have a look in the statistics from that. So just remember, on the PowerPoint part, you will have something like a normal distribution over here. You can check it in every band: 1, 2, 3, 4, 5, and band number 7. But normally you are not having just only one area of interest, and so you have to concentrate on all the scene, also on the whole extent of the scene. So this is a very bluish water body. You can also have some very dark water bodies or shallow water bodies over here. So we will create not only one signature or one example, we will create a lot of them. So using this again, go back to the signature editor, create a new file. This is class number 2. We will just leave the name now blank and go to this shallow water body. Once again, this could be very coarse, so you don't need to concentrate on the beaches or whatever. So you can just mask one part of the lake. So go over this, and why you should use all the whole extent of the scene is because this Landsat scene has a width of about 190 kilometers. So you can have some haze in the western parts and really non-hazy conditions in the eastern part, and this will change the way of reflectance of your bodies. So now we will have this once again, and now we are going up to the north. There's a big water body. Here we go. And one other part is if you're using signatures or training areas from areas that are close to each other, you will have some kind of problem of the spatial autocorrelation. So you should concentrate really on the whole extent, and your examples should be good to see. They should not contain any kind of mixed pixels or whatever. So I will show you that in a moment. Just extract the information here. Here we go. So just as an example, you can see the area over here. So we go in there. You should not go with this signature file.